there is one more thing I want to look at in today's lesson, and that is manometer problems. And now that you know how to do some conversions, you can work with these manometer problems. You'll have a little bit of practice with conversions on this. Plus, it's another way to think about measuring pressure. So it links the two lessons from yesterday and today just a little bit. So a manometer is different from a barometer that we talked about yesterday, or actually the last lesson. I guess it was last week at this point. But the difference is a manometer measures the pressure of a trapped gas. And so if you think about something like maybe an oxygen tank, a scuba tank, or I guess really even the air in your car tires, a manometer is something that could measure that. In the lab, we might have a flask that has gas in it. We need to know the pressure of it. So it's like a pressure gauge, essentially. Now, they don't really look like what I'm about to show you. This is just sort of a diagram that we use to illustrate what's going on. But basically, the way they measure pressure is they look at the difference between atmospheric pressure and the pressure of whatever is trapped. And like I said, this is not what they would look like. And we have other ways to do this, but this is one illustration of that. And so both of these are manometers. And notice I've got the pressure equals question mark. So this flask here, this little bulb, has the trapped gas in it. And that's attached to a tube. And this side of the tube is open to the atmosphere. These can be flipped around. This is not, it doesn't have to be on the right or left or anything like that. I just happen to draw both of these with the tubes here on the right, but it could be a mirror image. So don't get too caught up in having to look exactly like this. But the setup is the same. So whichever side the tube is on, it's open to the atmosphere. And so the pressure on the mercury, and that's what this little dark section here is, it's the tube filled with mercury, this U-shaped tube. But one side is open to the atmosphere. And you'll have to be given the atmospheric pressure at that time. And so it can be, it probably will be somewhere around 760 millimeters of mercury, a little higher or a little lower. But that's the pressure that's pushing down on this side. The trapped gas is pushing down on this side of the mercury. And so it's just sort of a balancing act. The side that is pushing harder will have the lower level of mercury. So if you look at this one, and I've written it out here, the trapped gas has greater pressure. It's pushing harder on this side, and it pushes the level of mercury lower. It's a little like tug of war, except instead of tugging apart, we're pushing against each other. And so since this one's pushing harder, it's able to push the mercury up against the atmospheric pressure. And so if that's the case, I'm always going to look at the difference in the two levels of pressure. But if the trapped gas is pushing harder, it has more pressure than the atmosphere, so I'm going to add the difference of the two levels to the atmospheric pressure. I've drawn this one with the opposite scenario. We still have the same atmospheric pressure in this one, but here the atmosphere is pushing harder because this level that's open to the atmosphere is lower than the level that's attached here to the trapped gas. So I've looked at the difference. This one's at 97 millimeters, this one's at 62, for a difference of 35, if you can read that. And so since the atmosphere has more pressure than the trapped gas, I'm going to subtract because the pressure here is less. The atmosphere is able to push harder and push that down farther. And so in that case, I'm going to subtract. So here's the math that I did. The first step, no matter which scenario you have, is always to find the difference in the levels. 126 minus 83 gave me a 43 millimeter difference for this one. 97 minus 62 gave me a 35 millimeter difference for this one. So again, looking at how the manometers are set up, since the atmosphere level is higher, that means the gas here is pushing harder. So I add the difference to get a final answer there of 801 millimeters of mercury. On this one, again, since it's the opposite of that, the atmosphere is pushing harder than the trapped gas, I subtract the difference from the atmospheric pressure and get an answer here of 723 millimeters of mercury. So that's really all there is to manometer problems. It takes a little thinking. You can memorize this if you want to, but I don't recommend it. And you can memorize when the level's lower with the gas you add, when the level's higher you subtract. You'll get it mixed up probably. Try to understand the dynamics here. Try to understand what's going on and why you're adding or subtracting, and you'll have a lot better luck. You won't get it mixed up if you actually think through the process there. So we're going to run through just a couple of quick ones of these. And I wasn't very nice to you when I made up these practice problems. I didn't give you millimeters of mercury. So we're going to do some conversions too, just for fun, just for practice. So here's a manometer, and the question is always going to be, what's the pressure of the trapped gas that's inside here? And so, like we said, the first thing that you always do is find the difference in pressure. So these two are pushing against each other. The atmosphere side is at 83, and the trapped gas side is at 62. And so when I subtract those, I get 21 millimeters of mercury. And so then I analyze, is the trapped gas pressure higher or lower than the atmospheric pressure? So looking at the setup here, this side is lower, this gas is pushing harder against the atmosphere. So I know that this is an addition problem. I'm going to add 21 millimeters to the atmospheric pressure, but I can't add it to the atmospheric pressure with the pressure in atmospheres. So for this particular one, I've got to do one more step. I just have to do a conversion. So 0.987 atmospheres. And hopefully you've got this written down handy somewhere. This is the table from the last video. So atmospheres to millimeters, the relationship is 1 atmosphere is equal to 760 millimeters of mercury. So we're going to put the atmospheres on the bottom to cancel them. 760 millimeters of mercury on top. So the actual atmospheric pressure in units that I can use for this problem, 0.987 times 760. So 750.12. Again, I'm going to use this number for my significant figures. And then kind of make sure that this makes sense. This is less than an atmosphere. That's less than the 760. So just that tells you that you did the math correctly. Just one more quick little check. And so we've already said we're going to add these two together. By the way, this should have a decimal because it's 3 sig figs based on that. So 750 plus 21 is a final pressure of 771 millimeters of mercury. Simple as that. One more. And, if you think you're ready to move on. That's fine. You can go straight to the practice problems. If you think you might need to see one more example, then here it is. So here's a manometer that's flipped around, opposite of the others that I had drawn. It's harder for me to draw them this way, so I tend to draw them like that. I don't know why. But anyway, this is telling me that the atmospheric pressure is 14.8 psi. I have a trapped gas here. The level is 38 millimeters next to the gas and 22 millimeters on the side that's open to the atmosphere. So for this one, I can see that the atmosphere is pushing harder than the trapped gas. So I'm going to subtract. But first I have to find what to subtract, and that's these two here. So 38 millimeters minus 22 millimeters is 16 millimeters. This is of mercury. So it's that pressure. I'm going to switch pens here because that one's about to die on me. And we just said we're going to subtract that because the atmosphere is pushing harder, so its level here is lower than the level here. It's pushing down against this and causing it to rise on this side. So 14.8 psi and millimeters of mercury do not match, so I have to do a conversion. My psi to millimeter conversion, 14.7 psi and 760 millimeters. So psi goes on the bottom so that it will cancel that unit. 760 millimeters of mercury goes on top. So 14.8 divided by 14.7 times 760 is 765.17. Again, 3 sig figs there, so I'm going to keep 3 sig figs in my answer. And then we said we're going to subtract these two. You don't have to write out this step if you don't want to, but I'm trying to show you everything that I'm doing as I'm thinking through it. So 765 minus 16 is going to be 749 millimeters of mercury. And that's all there is to it. So your next step is to go on and try some of those problems that are in the worksheet below this. So work on that, and we'll talk about any questions or problems you're having the next time we meet. I'll see you soon.